Hi, my name is Ken Lasseson. I wrote a Microbiome prescription website, and this is basically a talk for the nerdy or the ones who are more cognizant of the complexities of the microbiome. And the word complexity is an understatement, actually. Okay, one of the sources I used is the KEGG database, and you can just type in KEGG.jp. And what does KEGG stand for? It stands for the Kyoto Encyclopedia of Gene and Genomics. It is a publicly accessible, magnificently complex, up-to-date with all the current literature. And as you see, we have all sorts of things. For example, we can go down here and click Enzymes, and it goes and gives description and tons of information, which proceeds to get overwhelming for most people. Now, suppose we identify enzyme either by name or by number. We end up making a query to the KEGG database with the enzyme number here, enzyme number 1.1.1.10, and a magical page appears. This page is where I'm getting is the fulcrum of the data I'm using for the KEGG enhancements on microbiome prescription. I want to show you how and where I'm getting the data from, so you can go in and check yourself. Or if you have a question, so you can go there. Not message me, go there, because it is the authoritative source I'm extracting from. So it's where you should be asking questions, and not out of me, because basically all I'm doing is moving data around. Okay, so we have a particular type of enzyme. It has an official system name, which is listed there. We have also a bunch of alternative names, which are there. And like with bacteria, there can be dozens of different names for the same thing. There's no standardization, just like many people have half a dozen different names for themselves. My first name is Kenneth, second name is Martin. So I can go by Ken, by Kenny, by Martin, by Marty, by a variety of combinations. So same person, just different ways of naming it, and the name depends on whatever it is. When I was teaching high school, it would be Mr. Lasseson, or some slightly more impolite names. So again, lots of names, the same thing. And how do we know what we really are talking about? The magical enzyme numbers. So we have that. So we have magical enzyme numbers, and now we have, down below, we have substrate, which means things which are being consumed by this enzyme, and products, which are things being produced by this enzyme. And you notice we have a CPD number here. CPD stands for compound, which you sort of almost get from the abbreviation CPD, compound. And then we also have genes and a taxonomy down at the bottom. So first, let's take a look at this one. And if we simply open it in your window, you see here is the compound, chemical formulas, all sorts of things, pretty little diagrams, all things. And it shows also all of the enzymes involved here. So you could go over and look at a different enzyme if you want, and come back and there. So it gives you a whole bunch of links to other information. And we can go do the same thing for here, for example, H+, which is hydrogen ion. And we have it there, and you can see we have a ton of different reactions involved with. We have lots of pathologies involved with. Again, you can go and down below that we have all the enzymes that are involved with it, which molecules are in it. So if you can go down here and click that, and now you see how it is involved in one of literally dozens of different reactions. So it's involved in a lot of reactions, not a single one. So which one is actually happening is not a definitive thing. It has many candidates. Almost like saying, okay, here's $1 bill. I'll put it into a donation box. Where does it go? It could go many different places. So I could put in a $5 bill and take out a $1 bill. The $1 bill could go to a store to buy something from information, or it could go directly to a person who is short of money. Again, it's just a component which could move anywhere, and that's part of the fun, because it is like human society. It's complicated, it's complex. So we can find out the name of the compounds, including things like the chemical formula. Sometimes you may have alternative names showing up. H plus or hydrogen ion are two different names of the same thing. And then we're down here at taxonomy. So if I click taxonomy, it tosses you over to another page, and that other page will go and show you where that particular enzyme is found. And we have something to be aware of. We have some items which are red and some items which are green. Red indicates it is not found in that creature, but we're not interested in creature. We are more interested in bacteria. So we're down here in bacteria. When we open up, and we see it's not found in any of those ones. We can see it's not found in any of those ones. But the thing to notice is all these are different keyword strains of bacteria, not species or genus, but strains, much finer resolution. If you click on one of these, it will take you over and it will give you the information, including the NCBI taxon numbers. And if you click on that and open up in a new window, you're over at the NCBI, and it gives all the information with a bunch more links. Basically, we have a very knotted problem with data going everywhere in massive quantities. So, popular list will try simplifying it down by picking one or two threads and say, that's all you really need to know. I'm not a populist. I want to go for accuracy, and also I tend to handle complexity well. So I'm not overwhelmed by the complexity here. But basically, here we have here. So we have just information, and what information do we have? We have the name of the enzyme, we have what it consumes, we have what it produces, and we have what bacteria it is. So we have those 4 bits of information which can be mixed and matched all sorts of different ways. I took that data, brought it over to Microbiome Prescription, and if you go over here, and you will find that it sits here, and it depends on what level of display you have. These will generally require advanced or even nerd level to see them on the links. I have in the blog post the direct links to them, so if you don't see them, you can go to the blog post, which you should save as a favorite, so you can find it later and go over there. So what do we have? First of all, we have, let's take a look at species. We have all sorts of species here, and we have, in a moment, we have a total of almost 6,000 different species, which is more than what typically comes in our people. We of course have the joys of being able to do Bifido there, so you can go in and start typing. So we see Bifido adolescents has 354 compounds produces, 367 that it consumes. Another one, animals, has less and less. And here we have some no ranks. Some of these will probably be disappearing in my roll-up. I missed getting those properly rolled up, but then we have them victims. So you can see there are, at this level, you can see the actual differences between one strain and the next strain of a probiotic strain. And as you can see, there's a good long list of them, and we have 35 there, a bunch of no ranks, which will hopefully be resolved in my next update. And now if you say, okay, so let's go down and take a look and say, okay, so what does, key thing to notice, Bifidus animus lactis, we have 4 of them here, 5 of them here actually. And notice that each strain has a different number, and that ends up having a slight technical problem. The technical problem is when you roll up into a species from mixed strains, you have a problem as some strains have and some strains don't. I do a naive averaging so that what is in common is there and what is not as common is there a little bit, so that we get at least a better picture, because most of the time you will not get these coming back in a 6-Sinus lab report, which means you won't get any match for that. In other words, you'll get no information. But because they have a commonality between them, some cases pretty close commonality, like these two, which could be almost the same thing, just brother and sisters rather than first and second cousins, then we work on that. So it's a compromise because we are dealing with fragmented data and we are wanting to somehow kludge the data to be more accurate, more comprehensive than it actually is. Unfortunately, failing, but it's the reality of what data we have to work with. So that is an example for the species and there, and then, as you see, you can go down into each one and see what consumes and which one is there. It is not tied into your sample select. That is work in progress, and that may take another couple of weeks. Believe it or not, this update itself took almost 2 months of hard work, most weekends, most evenings, to get all the data in, correlated, corrected, and miscellaneous issues refined. Okay, so bear with me. It is coming to your samples, but at the moment it's not there. You do have a raw data, which is what will be used for your samples. Now, the other thing to go over there is if you go into, let's go through this one, and I'll click that one, you will see what compounds are being produced. But if I click here, you see that we have a number here, 72, and that is, there are 72 enzymes in this bacteria, 72 different enzymes, each produces this particular compound. So the old way, I just said, did it produce any compound? 0 or 1. Now I'm actually counting how many different enzyme producers, in the belief that it is going to be a good estimate for how much this particular bacteria produces of this particular compound. There, so the thymine, which is here, is 27. We can go to something else and see how many it produces, and in fact I may end up doing an additional page down the stream, but basically it gives how much is being produced by in theory 1 cell produces 27 abstract units. Here, less down to 4, down to 1. As you can see, we have 332 different compounds produced with just one type of bacteria, which is probably more than you expect. Most of the time you say, oh, it produces lactic acid, it produces hydrogen peroxide, 2 or 3 substances. 2 or 3 substances out of 300. The rest of the information that the populace and many naturopaths or even MDs won't even mention to you, because they are dealing with information overload themselves, and they are simplifying it down so far that they probably have lost some of the important details. Okay, I give you the important details and you can slug through it or get frustrated with the amount of detail. I'm sorry about the frustration, but I want things to be as accurate as you can make it. And so that something comes up, especially when we look at it, you can go in and you can get accurate information. Okay, so let's go back to lookup. We look at compounds. And how many different compounds do we have? We have 2,200 different compounds being done. Again, what we have is we have the ability to search. I'll put H plus there, hydron, or hydrogen ion, which is typical for, okay, I know I need to toss in there. I need to toss in formula. Okay, which is typical for SIBO. So you can see that, and you can say, okay, which bacteria produces this hydrogen ion, which is causing my SIBO? Oh, excuse me. There are 5,000 different bacteria. So which one is it? Good question. What you may want to do is go over there, and most of them is one, so don't worry about that. But if you go and click here, you can see ones which are higher producers, and those are ones which could be of concern. But again, interpreting is a separate issue. My goal is to get the information there. So we have compounds and who produces and who consumes it. And we have enzymes here, which is simply, page. There it goes. And these are the enzymes to produce. Here's the name of it. Here's the alternative names. Sometimes when people look for a particular substance, they think it's a compound, and actually it's not a compound. It's an enzyme. Just this morning, somebody asked me about stuff. He was particularly interested in beta-galactoside. Blah 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 blah. Sometimes I feel like it's Swedish chef with some of the names. And there was nothing there in the compound. So he was, but when are you going to add it? I stopped. I said, wait a minute, let's check. It's not a compound. It's an enzyme, which is different, which is handled in a different table. So you may have to check both tables. If you don't find it in one, you may want to find. There's a nota bene up here saying that you may want to go over, and you can just click across there. So here we have it, and we have all the different names. 90 down there with all the variations, and as you see, there can be a lot of variations to it. What you need to do is figure out which one of these ones are the ones you're really interested in. In this case, this one is the one which seems to be a precise match. We have the technical name here, and if you click here, it will take you back to KEGG, where I get the data from. So you can go and do what you want with it. Again, we have everything there. You have everything there, and the only difference is a very simple one. On these pages, things are linked back and forth with them, and the linkage makes it much easier. For example, here's something which has an enzyme but only 22 bacteria reduces. Which ones are those 22? Voila, there we go, and 17 is the count, and I know why. There's still a little glitch I have in the counting which I need to update. But there we have the ones which are the producers of it, and that's basically it. Okay, so at this point in time, I'll shut up and I'll explore. These three things will show on the main menu till March. Or no, till end of March, and then they will disappear, and you will have to set them to see them by setting your level to probably advanced or nerd in order to see them, or go to the blog post which this video is in and use the links there to get to the same pages. So you don't have to be a premium or nerd member to access the pages. It's just a little bit more inconvenient because you have to go to the blog post and then go over, but it's still there. So if you're willing to do that little bit of extra time, no problem. If you want to support the site and operating cost and have faster access, hey, donate away. So that's basically it. I think that covers it. Next thing is fixing a couple of data problems I see and want to correct. Once those are done, I will go and see about reprocessing people's sample through. getting the new numbers, new percentile, which should be a lot more informative. And with very incomplete data, I had some strong relationships. With more accurate data, I expect to get some real sweet machine learning and AI results out of it. Okay, that's it. Being an ex-teacher, I wanted to keep talking for hours.